Hello everyone, welcome back to our channel. Today we'll be solving a LeetCode question based on binary search, that is square root of x. Let's understand the question. Given a non-negative integer x, return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. So let us see the test case. Suppose we have input 4, square root of 4 is 2, we'll return 2. Suppose we have input 8, the square root of 8 is 2 point something. So we'll simply return the nearest integer, that is 2, right? Let us see the brute force approach to this question. We are given a number n. Let us say we'll take an example 28. And we have to find out the square root of 28. We'll start with 1. 1 into 1 is 1. This is less than 28, so we can move to the next number. Let's say 2. 2 into 2 is 4. This is less than 28, so let's move on to the next number. 3 into 3 is 9. Again, we can move on to the next number. 4 into 4 is 16. Let's move to the next number. 5 into 5 is 25. This is also less than 28. So let's move to the next number. 6. 6 into 6 is 36. So now this is greater than 28. 36 is greater than 28. So we'll take the largest number whose square is less than 28. That is 5. So if you see square root of 28, that is 5 point something, right? So here we'll return 5. Let's see the pseudocode. So we'll start with I is equals to 1. And we can go maximum up to n. We'll take answer is equals to I. And if for any number, the square is greater than n, we'll break. So the answer will give us the largest number whose square is less than n. What is the time complexity of this? Big O of square root of n. Now let's try to understand an optimized approach for this question. So here we can see our answer can be in the range 1 to n. So we have a range of answers, and for 1, the square is less than 28. For 2, it is less than 28. For 3, it is less than 28. 4, it is less than 28. For 5, it is less than 28. For 6, it is greater than 28. For every number greater than 6, this will be false. Right? Up to 28, let's say. Now you can see a pattern here. Whenever you have this kind of pattern on the range of answers, we use binary search on answer. So here we'll be using binary search on the range of answers. What is the minimum value for answer 1 and what's the maximum value? N. So we'll take 1 as low and n as high, and we'll apply binary search on this range. So let us start. So I'll take numbers from 1 to 28, 6, 7, and so on up to 28. Now 1 will be low and this 28 will be high. So we'll first calculate the mid. What is the mid value? 1 plus 28 divided by 2. This will be 14. So now if you check 14 into 14, this will be greater than 28, right? So now we are somewhere here. So every number which is greater than 14, we need not check that. So we can simply cross out that range and move our high to mid minus 1. So what I'll do is, now my high will go to mid minus 1, that is 14 minus 1, 13. So 13 will be our new high and 1 is at low. This is our high. Now mid will be 1 plus 13 divided by 2. This will be 7. Now this is our new mid. Now let's check for 7. So 7 into 7, this is still greater than 28. So we'll move to the left side. So now our high will be mid minus 1, that is 6. Now the range is from 1 to 6. Now this is our new range, 1, 2, 3, 4, 5, and 6. 1 is low and 6 is high. Let's calculate the mid. Mid will be 1 plus 6 divided by 2, that is 3. Now if I do 3 into 3, this is 9. So this is less than 28. So now we are somewhere on this possible range. 3 is a possible answer, but we can have an answer that is greater than 3. So we'll store 3 in an answer. And we'll move to the right side. So we'll also write low is equals to mid plus 1. So now low will come here. We'll store this value in answer variable and continue on our new range. So now our low is 4 and high is 6. Again, we'll calculate mid. Now what's the new value of mid? 4 plus 6 divided by 2. This will give you 5. Now 5 into 5 is 25. This is also less than 28. So in our answer variable, we should update it to 5. And then we'll still go on to the right side. So we'll increment our low to 5 plus 1, that is 6. Now our low and high both are at 6. So we'll calculate mid. Now mid will also be 6. Now if you calculate 6 into 6, you will get 36. So this is greater than 28. So this cannot be the answer. We'll move to the left side and we'll decrease our high to mid minus 1, that is 5. Now low is at 6, high is at 5. So low is greater than high. So we'll stop our binary search and the answer we'll return is 5. Let us see the pseudocode. So we'll start low from 1 and high from n. We can also keep an answer variable and we'll initialize it to 1. So now while low is less than equal to high. So here we are using the normal binary search approach. We'll calculate mid value, low plus high by 2, or you can do low plus high minus low by 2. Then we'll check if mid into mid is less than equal to n. So this means this might be a possible answer. So we'll write answer is equals to mid and we'll go to the right side. So we'll write low is equals to mid plus 1. Else, we'll discard the right hand side and move to the left part. Here we'll write high is equals to mid minus 1. When our condition will break, we'll simply return answer. Let us understand the time complexity. So here our range is from 1 to n. And what is the time complexity of binary search? It is log of the range, right? So the time complexity will be log of n. So we have calculated square root of a number in log n time using binary search method. Let us see the code. So you can find all the codes in C++, Java, Python, JavaScript in the link given in the description. Here I'll just show you C++ code. So here you can see we have taken low as 1 and high as the number given, that is x here. We have initialized answer to 1 and then we have used the binary search. So while low is less than high, we have calculated mid. Here we are converting the square of mid to long, right? And if it is less than x, we'll keep that in answer and move on to the right hand side. Otherwise, we'll move to the left part. In the end, we are returning the answer. Here we have also handled one edge case. If the given number x is 0, but we are starting our low from 1. So in this case, we'll simply return 0. That's it, guys. Thank you for watching. Make sure to subscribe.